Welcome everybody, and thanks for this opportunity, and thanks AJ for putting these on, and hopefully you get a lot of information out of this today. So just a little bit more about myself. Is husband, father, entrepreneur. Had a home inspection business. I sold it around the COVID year, maybe 2021 or 2021. Um, I was the education director for the new company for a little while. And right now, as AJ had mentioned, I'm teaching at Cecil College and at a night for home instructors. So a little bit more is I had 40 plus years in the home construction and remodeling business. So, full time, part time. Still actually do some work. I just finished up some windows yesterday for a friend of mine. So I'm still dabbling in the field a little bit, but it gets more and more challenging as the years go on. I spent 22 years in the customer service management technical field. I was an wireless systems design engineer, a project manager to implement these systems I designed, and then again, 15 plus years in real estate inspections and continuing education and training programs. Um, so just another quick, I believe life is short, so you should do what you love. By enjoying what you do, your entire life reflects it. I believe in maximizing your reach to help others, educating others, it empowers them. And I believe that gaining knowledge, wealth, and resources enables you to help more people pursue their dreams and passions. So, firm believer in having your beliefs and different things. So, just wanted to share that. So insulation and ventilation, there's a lot of questions and concerns about it, and I'm sure many of you are very familiar and know a lot about insulation and ventilation as well. But I'm just here to share some other insight, maybe a different viewpoint on some things. And there's a lot of different directions to go and so on from the insulation and ventilation. Um, so by the end of the course, I hope we're going to get a better understanding of installation and ventilation methods, identifying installation and ventilation areas of concern that have come up, from home, concerned buyers as well as real estate agents, to find how installation and ventilation affects energy efficiency, which is a big one. That's a huge part of this. Describe the impact on the real estate transaction and provide some answers to commonly asked questions. So one of the things I'd really like to emphasize is insulation and ventilation will provide the greatest return on investment or ROI than almost any other component of the home. I was doing some research earlier. I couldn't find specific numbers on insulation and ventilation. It just kind of reiterated that by providing insulation and ventilation, the homeowners will reap the benefits all the time. They'll have lower energy costs, including increase the value of the property by having lower energy costs. So a lot goes into it. Now, I know nobody's ever said, when, a lot of people put money in their home, and as visitors come over, everyone wants to show them all the shiny and glitzy things that they've done to their home, but nobody's ever said, "Hey, you got to see my insulation and ventilation. Wait till you see it. It's awesome." So, unfortunately, that's never happened, but it's a key part of owning a home is having the proper insulation and ventilation. It goes a long way. And so, yeah. So proper insulation and air sealing is a huge part of it. So air sealing is sealing every little opening that potentially air can leak through, primarily in your attic space, but as well as around your windows and any other openings as well. Um, so if you're ever in a home and it's a windy or breezy day, and if you can feel the cool air at an electrical receptacle outlet or a wall receptacle, that means it's not air sealed properly. So you can really know that it's a lot of wasted or lost energy or something like that. But it keeps the attics cold in the winter by blocking the entry of heat and moist air. from the inside the house below. Because as we all are aware, the house is like it's a stack effect. Hot air rises, moisture comes with it as air is moving. But also in the summer, natural airflow in a well-vented attic moves that superheated air to the attic, protecting the roof and shingles, the materials, removing moisture, which also, in a way, affects that return on investment. If everything's protected, there's a lot less money spent, fixing problems that you have if you don't have that proper ventilation. And then you also get improved indoor air quality as well. And we're going to go into that a little bit on the indoor air. That's a whole topic within itself. So I could go for talk for hours just on that topic alone. If anybody wants to share how insulation and or ventilation issue has affected you either personally or professionally, you can just share it in the chat window if you don't mind. I always like hearing different stories and how other people were affected and how they overcame those things as well. So if you wanted to share that. I'm going to skip the video and so the video, there's a lot of good videos out there that talk about insulation and air sealing. Air sealing is a critical part of it. Now, insulation alone will have a huge benefit. The air sealing just exemplifies and it multiplies the value of just insulating. But air sealing a old house or a house that's already been built is a lot more challenging than if it's a brand new built house. And a lot of your energy efficiency houses built today, they do air seal them before they're insulated. And the video just talks about how insulation without air sealing is malpractice. Um, so and these questions, if you also want to just post any questions in the Q&A section, if you have any, we'll go over a lot of those. Or you can put questions in the chat window as well. I'll review those at some point and we'll go over them. Hopefully get everything answered that you guys may have. There's just a couple slides. So I also use these slides as placeholders for myself. They're kind of like bookmarks to let me know when different topics have changed and so on. So, and I have a few quotes in here, but knowledge is power. That's a huge one. So the more knowledge you have, the more power you have. So always learning out there. So it's a huge one. So part one, we're going to talk about types and materials, installation methods and concerns, and air infiltration and air sealing. We're going to kind of get into a little bit details about some of them. So there's a lot of different types of insulation materials out there. There's a lot of varieties and variations, especially those that, inspect older houses. There's a lot of older type materials. And we're going to cover some basics. We're going to cover a few others. The most common is going to be like a typical fiberglass blanket, bat, and or roll are the most common. The blankets primarily used, you see them in basements and or crawl spaces. We mostly have basements in my area. I'm from up here in Pennsylvania. So we'll see them on mostly poured concrete basements. They'll actually attach a blanket, fiberglass blanket wrapped in a plastic and to the walls to help prevent, provide some insulation. But other than that, bats and rolls are very common, primarily used in walls and so on. So the different types of materials are going to be fiberglass, mineral wool is a really good one. I like mineral wool personally myself. I think it's a lot denser and it just fits in a lot. I think it's a lot cleaner of an application. I just did some insulation on my own house recently, and I actually used the mineral wool between rooms as a sound blockers or soundproofing as well. It works real well for that. There's also plastic fibers and some natural fibers. And the same thing with loose fill and blown in, which is mostly used in attic spaces, which I think I have a slide that says that, is again, cellulose product, a fiberglass, a mineral wool. They have a couple different products for blown in as well. So I have a few pictures of just different applications, one being applied. This is a fiberglass batch and rolls being applied in these pictures, these six pictures. Pretty common application process. Here's some blown in. Now I really want to point out the picture on the right here, that's this picture here, is now from an insulation standpoint, you can see that it looks like someone burrowed a path all the way along here from one end of the attic space to the other. Well, if that's disturbed like that, it doesn't provide an equal amount of insulation value. Therefore, that alone could create some problems about air, moisture and so on, getting into the attic space from the home. So if you ever see something that has blown in and it's disturbed, I personally would call that out just to let them know, hey, it's not, it's inadequate or it's not providing optimal insulation values and so on. And then there's also the spray foam and or foam in place. This is a newer product than the other two. The other two have been around a lot longer. Now, this has been around several years now as well. And I think it's an awesome product. Um, it talks about the different types of chemicals and materials used. It's really fascinating to watch the videos on this and the amount that the spray foam expands and it just adheres to everything. But that works really good. We're going to get into a little bit more details about the spray foam in the slides. Some other common insulation materials, cellulose is primarily made from recycled newspaper. Fiberglass products contain 40 to 60% of recycled glass. Mineral wool is usually produced from 75% post-industrial recycled content. So a lot of recycling process goes into, and makes it a lot of the products from insulation. But these are the most common types you'll find today. Like I said, you'll still find a lot of other odd anomaly stuff over the years, especially on older constructed houses. So one type of insulation that to be really concerned with is vermiculite, if anyone's familiar with that. Now, this was very common product used in the I guess 50s and 60s into the later 60s, and it was known to contain a high level of asbestos. So there's a big warning around, if you come across vermiculite. I have a couple pictures on another slide that went up. But some of the more common brands are the Zonalite, Halo, Limpet, were real common brands. They contain 15 to 100% of asbestos. Now there's, just my recommendation is to be careful if you suspect anything contains asbestos. It should be tested and have a lab really identify and confirm, yes, it does contain asbestos. And I believe many labs will even know the amount of asbestos contained, depending on the sampling size and so on. But many types of asbestos insulation, loose fill, pipe wrap, spray-on. They use spray-on a lot in the commercial industry. And then just knowing, friable is the kind that's the friable is more concerning in the sense that if it crumbles and you can touch it, you really get the fibers that kind of, pushed out from the crumbling. That's what friable actually is. But loose fill insulation, insulation wrapping, some block insulation. And so there's a lot of different asbestos materials out there as well. This just explains what friable and non-friable are. Non-friable are going to be your harder materials, the floor tiles, roofing shingles, harder type materials are considered non-friable. And there's really nothing wrong with them other than letting people aware that they can do it. Because unless they're damaged and crumbling and breaking them, then they become more of a concern. But here's just some pictures of some asbestos, different types of asbestos. It's a mined product, and they've been closed down for years. There's still some mines that are not being utilized, but they're they're just down, but they have the warning signs and so on. But that's how asbestos was actually taken out of the ground, and then it's processed and mixed in with material. It was I guess one of the hotbeds of something that was utilized in the shipping industry as well as commercial, and it just spread into the residential field as well from insulating material. There's some other pictures of some different types of asbestos. Um, the pipe wrapping on old boiler systems is very common, back then. And if product looks anything like, I don't know if you can see the cursor on there, but anything looks like the top right picture, it looks like this corrugated cardboard wrap material. It usually has some type of a felt material on the outer layer of it. You see, it's when it's damaged and broken, it's most concerning. A lot of not repairs, but the way they do this is instead of removing it, because sometimes removing this type of insulation is a lot more detrimental than leaving it in place, but they'll encapsulate it. They actually wrap it and they seal it and they put a special solution over top of it, and it's encapsulated so the fibers can't escape and go airborne and affect anybody. Um, this picture just shows some cardboard, almost like a drywall type material that has asbestos in it, and it's very odd. I haven't really come across this. I came across it a couple times. I've seen this where if they're old boilers, they would have it then like these like on the ceiling above an old boiler, so the heat just would kind of blast into the construction of the house. Um, there's a picture of some typical of vermiculite. If you guys haven't all seen this, occasionally you'll see the bags of the vermiculite laying around in attic space. Um, I remember growing up that I was one of six, so there was a lot of us, and we were in a small house. It was a duplex, and so we pretty much lived from the attic down into the basement. We were all over the house. And my brother and I actually shared the attic space. Now it wasn't finished. As a matter of fact, behind the walls, it was all vermiculite. Now I didn't know it then, but knowing now, and it was just somewhere where like we slept with it. And as a boy, I ventured into it. I'm sure to check it out to see what this all was back there. That was in the 60s and early 70s when I did those kinds of things. And now I know, and I wouldn't really do that or recommend it to anybody else. Again, does it contain asbestos? The only way to be 100% certain is to have it tested. My biggest recommendation is don't speculate. Gather a sample, send it to a lab for analysis. Reports are provided from the lab. So all you're doing is passing that through, or you can kind of write your own report from it. Um, and it's something that can always be added on to an inspection. We've always charged for it when we've done it. And some states just require certification to even be tested for asbestos. Same with lead and everything, but that's a different topic. So just be aware of what your state is or what you can do. But I would just the big thing is don't speculate. Have it tested, get a little sample, a little baggie, scrape some into it and have it sent to a lab recommendation. So again, any questions or anything, you put them in the Q&A box or put it on the webinar chat. We'll, between AJ and I, we'll figure out which ones, we got to answer and go from there. Okay. All right, so to continue with the installation, I talked about blankets, batten rolls, most common and widely available type. They're used, you see them everywhere in all the big box stores, the Home Depots, the Lowe's. They're available in different types of thicknesses. 16-inch or 24-inch centers, depending on how the construction is. Primarily in my area, we did 16-inch centers. It was very rare to see 24-inch centers. It wasn't something that was real common in our area. And you can get it with facing or without, and there's brass facing, or which is just a paper, a foil facing, or a plastic. They even have some insulation now that's completely wrapped in a plastic, almost like a baggy type material. Just so handling it for the general homeowner, you don't get as many fibers, kind of in your arms and so on. And it's very itchy to work with. Um, and the facing should face the heated side. So if it's not facing, if it's facing the cold or cool side, it's installed upside down or backwards or however you want to word it. But it should the facing should face the heated side. Again, not suitable for damp or high relative humidity locations. I have some pictures coming up that will show why. Um, in wall, these are some drawbacks. In walls, typically over time, the fiberglass insulation settles, and you get these real small gaps at the very tops of the wall cavities. Really the only way to even identify them is with a infrared camera, which seems to be getting more and more popular from a home inspection as a standard tool. It never was when I did home inspection, so I need to carry one. I had one, but I didn't really carry it around with me as a regular inspection product. It may settle in the attics over time where it compresses. We're going to get into different things about R values and thicknesses. But if you can see the tops of the joists and rafters and so on, it's too thin. And I've done a couple old houses way back that the insulation, the fiberglass insulation, has compressed over the years and probably was less than 2 inches thick. So it's not getting a whole lot of insulation value or R value out of that. It's also harder to seal tightly around obstacles. When the fiberglass insulation came out, they weren't as keen as they are today on air sealing, so it wasn't a big deal. So it doesn't really air seal real well around any kind of pipes or anything. But you it can be worked in and be a very good. Um, Here's some samples or pictures of locations when it gets wet. It kind of really gets saggy. If insulation material gets wet, trash, throw it out. It's probably going to be full of mold in a matter of time. It gets wet, it touches the ground, the surface, especially in crawl spaces, and then it acts a pathway, a sponge that sucks more moisture up. It's pretty messy stuff. And there's a picture up here at the top right, just shows on the bottom right corner. It shows probably from that window leaking, where it's leaked down. You can see the discoloration in the actual insulation. It really loses its insulation value or R value when it gets wet and so on. And installing it properly goes a long way. As you can see by the picture on the left here, that they probably just ran out of full rolls and they just started chopping up and jamming little pieces in there. And they, over time, will all be gaps where these seams are. Just the way insulation, moves and settles by itself naturally. The picture on the right shows some insulation tucked into a cavity, a floor cavity, and over time it compresses, from the weight of itself, and you get a lot of air gaps and so on in there too. It's just something to be aware of. So there's a couple more pictures of insulation disturbed. Looks like somebody really moved and pushed things around so they could see something better. And I'd write something up like that all the time about this disturbed installation. So on. Same thing with the picture on the right. It's harder to see, but there's a couple areas you can see the ceiling through it there, and they got some can lighting. There's all kinds of things. So, but it's just the disturbed and the fiberglass and so on. I think that's it. So the blankets in black, And in roll characteristics, 3.5 inch thick is typically R11. We'll get into the R value in another slide or two and talk about that. They do have some high density, there you go, insulation now that gets a little bit higher R value, 3.5 inch, and 3.5 inches is a typical 2x4. So 2x4 construction, 3.5 inches is about as high as you're going to be able to put in there. They have the 3 5/8. Well, that doesn't fit in a 3.5 inch opening. You already start with a compressed framework, and so it's going to lose some of that R value. And then they have 6 and 6 1/4, which is very common. They're the most common sizes. R19, and then they do have some thicker ones that go into higher R values and so on. But R19 is a very common one. We'll talk about it a little bit later. But in our area of Pennsylvania, the builders at one time, R19 was the required amount of insulation that they had to put in on a house that was being built. However, R19 is about half of what is recommended because we have such, massive heat and cold swings, temperatures, that we could have R38 in our attic spaces. And the builders are only building the R19, and it meets every spec at that time that was required. But, so we were just kind of calling them out and saying, hey, it needs, more insulation. So it's something that be aware of. And, like I said, I know that some of you guys are all over the country here. I'm sorry, like soil mat. Yes. Trailer homes are known to have soggy flat. Yes, absolutely. Yes. Trailer homes are known to have that. There's a lot of humidity up in there, and having it vented and so on goes a long way. So the loose fill and blown in, it's a lot of small particles of fiber, foam, or other materials. It's I recommend that we had insulation added to our house, and I was real keen to make sure they put the baffles up and seal these first where the overhangs are. Especially when they do blown in. Otherwise, you just fill all those open cavities for air circulation, and you cover all the soffits. So it's just being aware of that. Very common and versatile product, commonly used in attic spaces, like I mentioned. It can be used in walls. It's just easier to just spray out there, like that picture shows how it's being installed. Excuse me. Some drawbacks also: suitable for damp and high relative humidity locations, difficult to install in walls, although it can be. We actually had it installed when we bought our house. The garage was not insulated. We had the garage insulated, and they had to actually inject it into the wall. And we'll show a picture of that in the next slide or so. But it also may settle in attics over time, or if it's in a wall. And again, if it possesses, it reduces the R value, which is the insulation value. They're being injected into walls. It can be done from the inside or outside. They cut about a 2 inch hole, bore a 2 inch hole. Now we had ours installed from the outside because of vinyl siding. They took off a piece of vinyl siding, and they were able to bore a hole in every cavity and inject the insulation into each cavity. Now I don't know exactly how well it goes into the cavity, but they injected it into the cavity. The garage was a lot warmer than it was. So it works from that standpoint. And then they have pre-drilled plugs. They plug in each hole and they put the insulation back up, and we're good to go. But it can be done from the inside as well. It just requires a little bit more patchwork and so on with spackle and so on. Flow is, just some specifications of loose fill. It talks about the density and the weight, some different specs here. I believe these slides are available if anybody wanted a copy of the slides. and there's a couple of handouts that are associated with them that I believe AJ made available if anybody wanted to print anything out. Um, but this slide here with the specs, it really goes into the next slide, which is a concern in the sense of, especially if you have 24-inch on the studs, then it's the type of material used. The cellulose is not recommended because it's a much heavier product and we get some drywall sagging, which I'll show on the next slide. But for 16-inch centers, it's good. Um, If it's 5/8 inch drywall, it's good because it's flexible and so on. You could get something like this from just the weight of the insulation alone if it's not, considered as part of the overall install. Hopefully the engineers have had all calculated out. And so okay, put the hand. These are again just some different R values and dimensions of the insulation. Again, my big thing was if you go up into an attic space or anything like that, if you can see the ceiling joist, there's not enough insulation. I don't, usually the insulation to the tops of them, and you couldn't even see anything. Now, again, that's primarily in our area. I know there's a lot of question about like, oh, we're in a warm climate. We don't need insulation. Yes, you do. Unfortunately, I do have a video, but I'm not going to show that tonight. Um, that it also keeps the heat out of the house. So it makes the house much cooler if it's insulated properly, especially in hotter locations, warmer locations. So the spray foam insulation, it's a liquid foam insulation material. It can be sprayed, foamed in place. It's injected or poured. Uh, it's a really nice product. I think it's the best insulation product, and however, it's a lot more expensive, and we'll go over a couple of those different factors in the next few slides. Um, but it fills every void, like the smallest crevices. That's why it's used, the foam insulation primarily used for the air sealing as well. Um, they yield a lot higher R value than the traditional materials, which we just covered. So there are some plus sides to it, but it costs more. It's a matter of which one, works for that application. So there's also two types. They have a closed cell foam and an open cell foam. The closed cell foam is the more common. It's a higher density. It's a lot. It's not is if you touch it, you can almost determine if it's closed cell or open cell. Open cell will be a little bit more spongy feeling, but the closed cell will not. It'll be a lot firmer and denser material, and it's a little bit better of a product as well. The A lot of the hand spray foams you buy at your big box store, mostly open cell. It's a softer, spongier type material, but they work very well for what they're available for use. Just be careful on them, especially if anybody does any window installs. I've heard stories about people using the wrong spray foam around the window, and the window framing swells and it compresses, and then the windows don't go up and down. It's a mess to get them out. But they just got to be careful what you use. So using the proper spray insulation is critical, especially around windows and doors and so on. So which type to use for specific application? It depends on how you'll use it, what's your budget. Like I mentioned, the closed cell foam has a greater R value, provides a stronger resistance against moisture and air leakage, but it's also the most expensive to apply. So it's just a matter of it does the extra value offset the value of getting it to the package. So, when I priced it out for our house, it did not. So therefore, we did not use the street file. We used the loose the loose insulation was blown in the walls, and I added some in a crawl space, small space. The open cell foam lighter is a little less expensive. It's still more expensive than any other insulation product, but it's less expensive than the closed cell. So there really is, say, which one is consult a professional insulation installer to decide which type of insulation is best for the application. Is really the way to go. I'm not an insulation expert, and neither we are most of you. Maybe some of you are. Um, again, spray foam typically costs more than traditional bat and blown-in insulation. However, some of those values may be offset because you don't have to do the air sealing if you use a spray foam, because spray foam is air sealing. So it's just there's a lot more goes into which one should I use type one. So here's another couple pictures of the foam being utilized. You spray it on, it expands enormously, and how it can all be used and so on. It's sealed real nicely. Uh, the big drawback is it's huge. That's about the only drawback there is to it at this point. I don't think it's been around long enough to determine if it really has any other drawbacks at this point. Here's just a quick comparison of the different types of insulation. A higher R value is going to be your foam insulation. There's your values, smoke and fire retardant. But the foam insulation is it's a better sound barrier. So there's a lot of other benefits to it. So this actually a really good slide if anybody's doing any type of things or anything. They use back. I'm sorry. All right. So again, any questions or anything like that, put them in the Q&A or in the chat, and we'll try to go through them after and if we have all these questions answered. Um, so just a little quick thing I want to talk to you about R value. It's the insulation material's resistance to conductive heat flow is measured or rated in terms of its thermal resistance, or R value. It's a technical term. It's good to know these things. You don't need to do any calculations and figure that all out as a home inspector, but it's good to know them and be aware of them, and where things go, and you can explain this to the clients as well. Again, the R value depends on the type of insulation, the thickness, its density. So a lot goes into the determining the R value of it. On a multi-layer wall, which every wall is a multi-layer wall, because you're going to have your drywall, your insulation, maybe a moisture barrier on the inside, maybe. And then you have your sheathing on the outside, or whatever finish siding you may have, or stone or brick or any other type of materials. Stucco is another big one. That all goes into the overall exact value of the entire wall. So there's a lot that goes into it. It's just not hey, that insulation is this thick, therefore sell the R value of that wall. So a little bit more goes into it than that. Depends on the climate, how much you need, depends on the climate, the type of heating and cooling, what part of the house. And I'll have a chart on here that shows the different zones that everybody's in. And that's going to determine, then there's another chart that says the recommended insulation for those zones. So I know I have slides coming up that shows all that. Insulating that is compressed will not provide the full rated R value. So that is a big concern, making sure it's not compressed or damaged and so on. Overall value of wall filling was somewhat different. We talked about this already. But there's also thermal bridging. Be aware of that. So I showed some of that. Sometimes it's really easily visible. You can see the thermal bridging, or ghosting, it might be called in some places. But this is what it looks like. You can actually see where the wall studs are in that wall, because the The wood, the 2x4 wood, has a different R value than the actual insulation. Therefore, you get this thermal bridging. It's actually affecting the pigmentation in the coloring of the paint. So if there's a contractor grade paint being used, it's more, you're going to have more common to see some of this thermal bridging. If it's a higher quality paint, it's not, it doesn't have so that alone, be aware of that and see that. That occurs, and you can really see it on an infrared camera as well, and depending on the temperature on the exterior at the time. So you have this thermal bridging that occurs. We had this. I didn't realize how bad it was. We have a room. We just had a couple of rooms painted upstairs, and until we took all the furniture out, and I was redoing the floors, the amount of thermal bridging was enormous. Now it was a cheap paint that was used, it was pretty old. So, and then here's our chart. It shows the different zones that we all live in here. Now I'm right on this border of 4-5. I'm right down here in the northwest area. That's our northeast area, Pennsylvania. So we're kind of on the cusp of 4-5. Um, but the next chart, so we got our zones, and then we just lay out our zones 4-5. And you say here's the attic recommended for our attics in our area, 38 R60. R38 is 12-13 inches of typical insulation. R60, we're going to almost double that. So just to get an idea of how much insulation is recommended for each area, kind of, go by these two charts here about and then it shows the floors and crawl spaces, 2x4 construction, 2x6 construction, and so on. They're limited on the walls because of what they're made out of. Now, unless you use foam in the walls, because it has a much greater R value, then you're limited on fiberglass. R19 is about as high as you're going to be able to get with a 2x6 wall, and R13, R15, the high density insulation sits in a 2x4 wall. So there's another little. So this talks about the benefit insulation because from the winter and summer. This is kind of it for our area. Everyone's area is going to be a little different. But the insulation keeps the cold, in the winter, insulated properly, keeps the cold air up in the attic space, and it prevents that moisture from within the house to escape through, especially any kind of air gaps and so on. Gaps might be lighting fixtures or any other type of fixture, or even just a gap alone of where the drywall in a corner or a seam might be, that if it's not air sealed properly, it could have a potential area where some air gets up in there. And or that moisture and so on, the whole attic space, it creates ice damming in the exterior. And we're going to get into this a little bit more when we get into the ventilation section. And just checking my time. Oh, wow. We're going to have to speed up a little bit because I really want to get into the ventilation side. That's a huge part of this. We got 15 minutes about. So, so here's just a hybrid installation. Again, it's showing the comparison of fiberglass, some blown or spray foam, and then a combination fiberglass and spray foam, which is it gives you a much higher R value. Here's your R19 in a 2x6 wall, which you can get a R33 if it's foamed, and so on. Here's the R26 combination. So again, this is another picture of those zones and the different R values associated with it. I'm gonna go through these. I'm going to get to the ventilation section, which is coming up. So again, highest R value in insulation, closed cell. You can see the closed cell spray foam is almost for your fiberglass and cellulose loose cast and so on. So that's just the value from the insulation standpoint. So the importance of air sealing, again, I mentioned, I'll reiterate, air sealing is a huge, huge part of it. It's not a showstopper, but it's very difficult to do in houses that already have, adequate insulation because you have to move all the insulation out of the way, do the air sealing, and then put all the insulation back. So it's a very labor intense process. That's why it's not done too often, but it is very effective, especially in the attics and crawl spaces area. Um, Again, and air leak occurs when outside air enters and so on. These are just different types. There's a tips. There's a handout. It gives you tips for air sealing. That's one of the handouts that's available to you. This is what it looks like. I'm not going to read each of these. That's on the handout. And then air sealing. It would air seal all these openings possibly to prevent any air escaping up and through this. Insulation, yes, it's controlling moisture. Actually, so a lot of air. So with air currents, this is how air and moisture flows in the air, either with the air currents, like diffusion through materials, like heat transfer. Air movement's the most common. That's how you're going to get the most. So if you don't have that air moving through, you're also containing the moisture, and the moisture is a very key component because, as we all know, moisture air feels cooler. If you're so you want to really contain that moisture so that the moisture is from. This is talked about diffusion and heat transfer. It's not as great of an effect. So no matter how many mistakes you make or how slow you progress, you're still way ahead of everyone else who isn't trying. So that's the end of the installation section, but I want to get into ventilation. Hopefully we'll go a little over maybe. Um, we want to talk about an overview, how much is enough, balance system, and potential health risk, health effects. So ventilation is the intentional introduction of outdoor air into a space and is mainly used to control the indoor air quality. This is a huge benefit to proper ventilation is the indoor air quality. If I had mentioned that way at the beginning. Again, it's talked about different ventilation, maintain essential ventilation, unwanted leaking around pipes and ducting. It's going to be the air sealing, the stack effect, or how to breathe naturally. It's really containing that so you can kind of control it. Unwanted drafts, leaks and gap, traction ceilings, and so on. There's a picture of some ventilation. Again, just light fixtures. If they're air sealed, you don't have that potential moisture in the attic space. The attic is one of the key areas to have it vented properly, insulated and vented properly. Ventilation goes a long way. Um, we're going to kind of bypass this slide here. Mechanical and natural. That's two primary types. Natural is it's a flow. Nothing's moving it. Now, if a house has a stack effect like this picture, you're going to get natural breathing. A lot of this, you can control this just by windows. If you open the tops of your second floor windows and open the bottoms of your lower floor windows, you create a more of a stack effect and you get a nice air circulation within a house. This is just showing that stack effect and how it works. This is mechanical ventilation. I really never didn't come across in the 15 years, very rare to have a mechanical ventilation in residential. It's very common in commercial, especially with the COVID and everything. It's required to have a certain amount of air exchanges in the commercial environment as opposed to residential. So we came across very few of them, but they were here around the country. So two critical factors about ventilation, how much is enough and balanced system. But there are two critical parts of ventilation. I want to make sure I cover those. and 49 or 60 of the north. Oh yes, absolutely. Yeah, sorry. So I was looking at the chat and saw that, but yeah, our 49 to 60 up north. That's correct. Yeah, because we're R 38 here in Pennsylvania, so anywhere above us is going to require a good bit more. So sorry. Back to so again, we're going to talk about how much and balance system. Now, I want to go over a lot of different calculations. We don't, as home instructors, we don't need to know the calculations or do the calculations, but being aware of them goes a long way. Um, so, how much is enough? And attic, the do calculation for attic, the amount of ventilation is 1 square foot of free airspace per 150 square feet of area space. So that's a quick calculation. Then I'll get into the balance system in a little bit. So how much is enough? Again, 1 square foot of free airspace per 150 square feet of area. That's how much ventilation is recommended in attic spaces. But as a home inspector, you don't need to do the calculation. It's a good practice to be aware of it, so you can kind of share that with the clients. So here's that where it says rule of thumb for attics and so on. But household livable space is the basic ventilation rate. Now this is in 2003. 7.5 cubic foot per minute per person, plus 1 cubic foot per minute per 100 square feet. In 10 years, in 2013, they changed that to 7.5 cubic foot per person plus 3 cubic foot per minute per 100 square feet. So the increase alone over that time period was 89%. That's a huge increase in 2003 to 2013. Today it's even higher. And I'm trying to think, I think I looked that up recently. It's on the next slide, I believe. So that's in a house. Now, the rule of thumb was, or what I always kind of really put out there is if the attic is insulated and ventilated properly and the basement and the crawl space, depending on what you have, was vented properly, the rest of the house takes care of itself. So, but anyhow, there are calculations to determine how much ventilation is needed in all areas of the house. Um, So ventilation today. Now these are three different methods of doing it today currently. The last one was from 2013. I looked these up maybe a week ago and added them in here. So you take the number of people, multiply it times the 7.5, take 1% of the square footage of the house, and add it to the number you got. It's one. So there's that method, there's this other second method, there's a third method. It's a quick method to determine how much ventilation they should have in a typical living space, the rest of the house. The attic is still that 1 cubic foot. So just being aware of knowing how much ventilation should have. Now, the other key point that I mentioned is a balanced system. This is critical to having the proper amount of ventilation. Balanced system is equal amount of exhaust as there is intake. Total free vent space divided by 2. Now that means when you do the calculation, as I said, about the 1 square foot per 100 square feet, I'm sorry, 1 square foot of free vent space per 100 square feet, 150 square feet of area. Once you calculate that number, if you divide it by 2, means you should have that much intake and that much exhaust. And without having the balanced system, you don't have optimal ventilation, and it could cause problems in the attic space. The attic space is the most prone to have some problems, and so is the crawl space because you have the earth is our crawl space, unless it's sealed properly, which it isn't in most crawl spaces in our area. Um, so just having that, and then all your materials. Oh, I have to speak that one also. Um, oh, the roll ventilation place, the ABCs. ABCs is the ample, so having enough ventilation, having a balanced system is a critical part, and controlling the air leakage into the attic from the conditioned living space below, which is air sealing. They all go hand in hand together from that sense. So, AJ, we're going to run a little bit over, I believe. I
That's
think you said
fine.
that was okay. Okay. All right. So then we have the balanced ventilation system. This is a mechanical system here. Like I said, we didn't have too many of these residential, but this is one way to get those air exchanges and get the air moving. I've always recommended to constantly have air circulating within a house. I put in ceiling fans in almost every room, and they're almost always on. And we have a variable speed um, blower fan in our heater is always on as well. So it's always circulating the air, and come springtime, as I mentioned earlier, with the house having that 7%, you can open the tops of the windows on the second floor and the bottoms of the windows on the first floor, and you can create that whole circulation of air within your living space. In the attic space, it's just doing the calculations and having a proper amount of exhaust and intake to get all that high humidity and hot air in the summer months of the attic space, or keep it flowing, so you have all that. Um, Again, this is just showing that mechanical ventilation, how it utilizes the ductwork system within a house, and it just does the air exchanges. It takes the outside air and so on. Again, more common in the commercial world. Here's another one just showing again in the commercial world. The benefits of having the proper ventilation is especially getting excessive moisture out, household chemicals and other pollutants. These chemicals and pollutants are just in every product you put into your house has chemicals and pollutants in it. Furniture, the carpeting, the drywall, everything. So getting all that moving around and exhausted out is a key to having a better indoor air quality. It also takes care of all your dust particles, dust mites, sand or pollens and so on. Get it moving. I'm going to get to it tonight. But another key part to the ventilation is having the proper filters in the systems. However, you're moving the air, putting the proper filters in place is a huge benefit to that. But here's some more benefits: tobacco smoke, combustion byproducts. Just get it moving, getting it out. I'll probably skip some slides coming up. Ridge and soffit vents are the most efficient for attic space. Um, they're most efficient because once they're done, especially a ridge vent, because it covers the entire length of the house, so you get a nice even flow and exhaust. The same thing with the soffits. The soffit vent should be open. One thing I would teach my inspectors is when you go into an attic space, if you can't see daylight out through the soffits, air's not getting through, or enough air is not getting through. So it's really just looking for daylight. Don't even turn a light on if there is one yet. Look for daylight first, and make sure you have the proper, intake and exhaust, and they should be equal to create a nice even flow. New fans are good, but they're central. They move a lot of air, but so they're not really positioned in optimal locations at the highest point. You could have gaps on where that ventilation actually occurs. Gable vents were original vents that you had in houses, and it would work really good, but it would only vent the top 4 or 5 feet of a house, really, and they're supposed to be exhaust. Now, if you have too much exhaust, they actually are counterproductive in the sense that if you have a ridge vent and a gable vent, your gable vents become intake because you have your dross above it, and it creates the air circulation right around that location. So just having the proper ventilation is the critical part of keeping the house, much better quality. So here's a picture just showing the cool air, or it's cooler air. It could be 100 degrees outside, but it's cooler than what's in the attic. It comes in through the soffit. You have your baffles, so the insulation should never touch the roof decking, and the air flows and it comes out. It comes out your soffit vents. Next picture just shows another pictorial of it. Again, it shows the actual baffle. If you don't have the proper insulation and ventilation, you can get a lot of ice damming that occurs right in this location here. That's a sign of lack of ventilation and or insulation is ice damming. So that's kind of a common problem area. These are just some pictures of a few different types of ridge vent. Um, Here's another ridge vent. These are just actual roof vents. These are better than not doing anything, but they're not really efficient. Where a ridge vent, like I mentioned, it covers the entire ridge typically. And all these materials, including the next picture, I'm going to show you some soffit vents. The manufacturers have a spec sheet that says how much free airspace per foot of run, per square foot probably, of these types of vents. And that all has to be done into the calculation to determine if you have the proper amount of insulation and ventilation. So it's a whole process. It's not just a quick, here's the number, and then you calculate it out real quick. So you really have a lot of thought goes into it. And it's critical, especially in the attic spaces, to have a balanced system and equal, and the correct amount. So here's some ventilation, some benefits of ventilation in the attic. If you get droplets from the inside, there's too much moisture in there. It's not getting vented properly. A lot of problems can occur. You can get mold growth, spores, mold. You get the wood, the roof section rots from the inside out. If you see little rust on the inside of nails, it's usually an indication that there's too much humidity in the air in the attic space. Typically it's lack of ventilation. So there's a lot of things that occur. Here's the one that has a roof vent on it. Well, that one area is working good, but if you have the ridge vent, it really just provides a lot more equal balanced system. Excuse me. This next slide just shows some pictures. This is actually ice forming on the inside because with so much moisture and it's cold out there, you can see a lot of discoloration on the wood decking here. There's a lot of ice damming. These are all signs of lack of ventilation and some maybe insulation. And you can see here, there's no way you're getting airflow, with that insulation jammed up in the chambers like that. There's no way the air is getting in there. Um, this is a significant amount of mold growth or potential mold growth. Say potential because just like asbestos, you really should come out and say, "Oh, you got mold growth," unless you take a sample and send it to a lab. Let the experts make that determination. And it's another service. Almost every house, from my perspective, has conducive conditions to justify recommending having a mold sampling done. And if you also offer those services, it's just some more added, value to the inspection that you can provide. But without the proper ventilation, now this picture at the bottom and the one at the top right, it shows now the old actual asphalt shingles were more problematic in this were more so than your newer shingles, although they're asphalt, they contain a lot more fiberglass layers. You don't get as much cupping and curling like you used to on the old asphalt shingles, but it still occurs. So this damage is being, amplified because of lack of ventilation and insulation in the attic space. There's another, here's crawl space that has the dirt floor in it. It's just showing, there's no insulation in there. Again, crawl spaces, the calculations are very, very close. Now, the calculations, I'm going to show this next slide, because the calculations change if the crawl space has a vapor barrier on the floor. And it's a significant change. So you can kind of see here that it's, if there's no barrier, it's the same as the attic space. But if there's a vapor barrier, it's 1 square foot for each 1,500 square feet. So it's like 10 times different if you have a vapor barrier in a crawl space. And those louvers they put in crawl spaces are almost useless. So you have to have that air actually circulating and moving around a little bit. Again, crawl space foundations. So here we're going to talk about if any single element is most destructive to a home, it's moisture. So air circulation, ventilation, all this moisture moving gets it out of the house. And that is a key component of proper ventilation. Moisture can bring down a house in a short living. Some pictures of some insulation in crawl spaces. These are actual houses that I've inspected. And they're a mess. This next slide, I want to show you one that shows you. This here is a basement of an old farmhouse, and this is a cobweb layer, and you can see the droplets of moisture on this web. That's how much moisture was trapped in this basement because it wasn't vented properly. And you can see the droplets on the ceiling and so on. It was bad. This next one is a crawl space that you entered that you had to be careful. I did hit the bottom of one of these, and my body became the sponge that, like, you could see the droplets trying to like facing you down. So it gets really bad in crawl spaces, especially uninsulated ducting. Is during especially the heat, summer months when you have air conditioning running through that, you get really bad. And then this is the ideal situation where you have the sealed crawl spaces and basements. This is really ideal here. For dehumidifiers, just real quick, I'm real close to the end here. Dehumidifiers, I always looked at them and said, well, they're better than nothing, but only by a little bit, because they don't actually take the air out. They just take the moisture out of the air. The same air goes back into the space, and it's just a vicious cycle. And if someone doesn't empty them or if they're not done, you're just putting moisture back in the air. It's just, they're, like I said, they air moving a little bit. There are other tools or devices. Now this Wave, that's a brand. So there are other brands. Actually, Wave, I believe, is out of business for some reason. I don't know why. But they have a system that takes the damp, moist air at the bottom of the floor, it exhausts it out, and in turn replaces it with the dry, climate-controlled air from the livable space. That would be ideal for basements and crawl spaces to get the proper ventilation going. It's just a little bit more on waves, relative humidity levels. Going to contribute to the amount of moisture in the house and getting ventilation, working properly is really going to help that significantly. A person exhales 200 milliliters of water vapor an hour, and that's why they recommend the air exchanges and other types of ventilation and so on. So the number one cause of mold growth in a home is excessive high or excessive relative humidity levels. So you control that humidity levels, you can control the mold in a house. So just ventilation is key, especially attics, the ridge and soffit vents, basements and crawl spaces, kitchens, baths, laundry rooms, and a balanced system is critical. Equal exhaust and air intake and so on. So The big one, proper insulation and ventilation improves energy efficiency. Like I said, biggest return on investment, reduces potential air pollutants, improves overall indoor air quality, providing a more happy home and so on. So again, in the comments, if you don't mind, if you want to share something you learned today, I'm going to end it here and say thank you all for attending. And hopefully you got something out of this, and I always enjoy doing these. Thank you. Oh, just sorry, one more last quote. Quality and service of product is not what you put into it, it is what the client or customer gets out of it. So, thank you very much.